Good afternoon, learners. My name is Mr. Paul Chilola once again. Welcome to Black Slides Online, the place where you learn the sciences, namely physics, chemistry, biology, agriculture, mathematics. Welcome to our revision sessions. Today we are going to be looking at how you can write descriptive answers in physics paper 2 and the chemistry paper 2. Welcome once again. In case you are watching this video lesson on our YouTube channel, Black Slides Online, consider subscribing to the channel and also hit the notification bell. This will enable you to receive notifications every time new material is uploaded. If you're learning on our main classroom, Black Slides Online, remember to download papers, pamphlets, workbooks, notes, and other materials, and study independently. Welcome once again. So we meet now to continue discussing how to correctly answer descriptive questions, which is question 1 and question 2, in either physics paper 2 or chemistry paper 2. Welcome, learners. So without wasting your precious time, I'll take you through physics papers selected randomly from different mock papers. Pay attention to the tips as I bring them forth to you, as these will help you to get the maximum allocated marks in your exams in physics and chemistry paper 2. I present to you a paper from NED. This is physics paper 2. Once again, I've always encouraged students or candidates to know their paper structure. Knowing the paper structure is gateway to doing well in such a paper. So physics paper 2, I'm sure there's a mistake here. This is talking about paper 1, because paper 2 doesn't have 13 questions, it has 4 questions. So this, I believe, was just an anomaly when editing this cover page. So we can ignore the fact that there are 13 questions in this section, but all other instructions apply. So you may use a calculator, and also maximum number of marks for each answer is indicated. Usually paper 2 questions carry 10 marks each. When you finish, you are advised to tick against the questions that you have attempted on this table. So you tick here. So without wasting precious time, let's get down to the business of the day. So section A, you are called upon to answer all the questions in this section. It should be questions, not just question. So with the aid of a well-labeled diagram, or well-labeled diagrams describe an experiment that can be carried out to demonstrate that resistance of a medium or medium affects the speed of an object falling through the medium. Your description should include 2 identical ball bearings, water, oil, 2 transparent jars of the same size. So we are already told the materials here. There will be no need to list the materials independently. So just go straight to answering the questions. The question. Welcome learners. So with the aid of well-labeled diagrams, remember that by just drawing a diagram, you already have 1 mark before you label the diagram. That's 1 mark. So draw a correct diagram. Drawing a correct diagram before labeling it, you have 1 mark. Labeling any 3 correct parts gives you 2 marks. So on the diagram alone, you have 3 marks. 1 mark is for drawing a correct diagram before labeling it, and the 2 marks for labeling 3 parts correctly. So the diagram that is desired for this question is simply this one here. Take note that the diagram represents what has been mentioned. So we have 2 ball bearings, identical ones. So we have ball bearings. We have a ball bearing here, another ball bearing there. Water in one of the cylinders. So water is a medium. Remember, medium means substance. It can be a liquid or gas. So in one cylinder we have water, in another cylinder we have oil. We have 2 identical balls. So by just drawing the setup, you have 1 mark. And by labeling the the balls, the media, in one case you have water, in another we have oil, and a ruler for measuring the distance. You have 2 marks. Altogether you have 3 marks from this setup. Welcome learners. So you need to strive for 7 more marks to make it 10 marks. Welcome learners once again. So you begin by saying arrange the apparatus as shown above, but on this page, this is to the left. On your paper, you'll be required to draw a diagram first, and then below it you give the description. Arrange the same at the same time. By saying at the same time, 1 mark. Release or drop 1 ball in the jar containing water and another in the jar containing oil. So these are released at the same time. Here your observation is based on which one of these will reach the bottom first. Which one of them will reach the bottom first? Release the balls or drop the balls at the same time. by saying at the same time 1 mark, release or drop one ball in the jar containing water and another in the jar with oil. So you have 2 marks there from this point. Record the time for each ball to reach the bottom. So you record the time taken for the ball to reach the bottom of the container containing water, and you also record the time taken for the ball bearing to reach the bottom of the container that contains oil. So record time taken for each ball to reach the bottom of the jar. So your observation is based on the time taken for each ball to reach the bottom. So compare the times taken for the balls to reach the bottom. Then you conclude by saying, if the time taken is different, then the resistance of the medium affects the speed of an object falling through the medium. Do not conclude by saying, it will be observed that the ball falling through water reaches the bottom first. No. Don't say the result based on your experience. Whether you did this experiment at school or not, do not conclude by telling that the ball in water will fall to the bottom first, or the ball in oil will reach the bottom first. No. You have to say if the time taken is different, then the resistance of the medium affects the speed of an object. Many people fail to get 10 out of 10 because of the way they finish down here. Remember that you're just describing the experiment. You have not done the experiment, you're just describing, you're explaining to someone who would like to verify or to show that resistance of a medium affects the speed of an object falling through it. So we have 3 marks for the diagram. Drawing the diagram 1 mark, labeling the diagrams correctly at least 3 parts, 2 marks. Together you have 3 marks, and 7 marks from the description. This gives you the total mark of 10. Question number 2. Describe an experiment that can be carried out to determine the length of a wire of resistance to 2 ohms given a row of wire. So you're given a row of wire many meters long, and from it you want to cut a length which will be equivalent or whose resistance will be 2 ohms. So how can you determine the length of such a wire given its resistance as 2 ohms? Describe an experiment that could be done. So here we don't need a diagram. As a matter of fact, in the manual papers, when there's need for a diagram, they will always leave space for you to draw the diagram on it. So here it's just describing, and no diagram is needed. And also make sure that your points agree with the number of marks indicated. So this is 10 marks. What it means is you should produce 10 good points for you to get all the 10 marks. Welcome, learners. So connect a series circuit with a voltmeter, ammeter, and a gap across the voltmeter. By saying this, you have 2 marks. This is a setup. So connect the series circuit with a voltmeter, an ammeter, and a gap. So maybe up to here it can be 1 mark, and the rest of the sentence another mark. That's why we have 2 marks here. Welcome, learners. Measure any reasonable length L1 of a wire from the row using a ruler. By saying measure any reasonable length, it can be 10 centimeters or let's say 30 centimeters, it's all up to you. Measure any reasonable length L1, call it L1, of a wire from the row using a ruler. Then connect that wire across the gap which you left there. So connect the wire of known length across the gap, and then note the voltmeter and the ammeter readings. Note does not mean record. You are simply looking at the readings, that's noting. Then you record the voltmeter and the ammeter readings, so 1 mark each. Welcome, learners. Calculate resistance R1 by dividing voltage by current. This is applying Ohm's law. Remember, using Ohm's law, you can calculate resistance. Resistance R is equal to voltage divided by current. Then you let 2 ohms be resistance R2 for the corresponding length L2 of the wire. So it is this L2 that is needed. All right. So calculate the length L2 using the formula L2 using L1 over L2 multiplied by R2. So R2 here is the given 2 ohms. So in this case, the value of the required length is simply going to be the ratio. I think there's a, a problem here a little bit. This must be R1. Thank you. So to calculate the resistance, the length, you use the formula L2, which is what is needed, goes to L1 divided by R1 divided by R2. So this simplified will give us L2, the length. Welcome, learners. Let's also look at a paper from the Central West Education Division, practical paper. As usual, this has 4 questions. You need to indicate write your answers in the space provided. So this is the structure of managed paper. Question number 1, with the aid of a diagram, describe an experiment that can be used to determine the spring constant of a spring using known masses, a ruler, and a clamp, as well as a clamp stand. Once again, you are told the materials, so there's no need in your description to To list the materials independently, just go straight to describing. And you already told, must use a diagram. Spring constant will be determined from Hooke's law. Hooke's law says that the force on a spring, or rather extension of a spring, is directly proportional to the force acting on it, or F equals to Kx or Ke, where F is force, K is spring constant, and E is extension. So to find K, we just need some values of F and E, and then we plot a graph. The gradient of such a graph will give us the value of K. That's a plot of force against extension will produce a straight line whose gradient is going to be K. So that should be the target when you're describing this experiment. So the diagram that is sought after, remember that drawing a correct diagram, before you label it, it's 1 mark. So we have a spring, we have a ruler just beside it. Before the spring is loaded, in other words, before a mass is put there, this will give you the original length measured from the ruler. Original length can be determined before you put any mass there. And upon putting a mass and non-mass, masses, the spring is going to increase in length by a certain amount, which is called extension. So the new length, subtract the original length, will give us extension, this bit here. So that's the setup. Drawing correct diagram, 1 mark, and labeling correctly, at least 3 labels, you have 2 marks. Already that gives you 3 marks from the diagram. Welcome, learners. So clamp the spring vertically on a clamp stand and fix a meter rule beside it. That's shown here. So clamp spring vertically. This is the spring clamped here vertically on a clamp stand. And then we place a ruler beside it. Once that's done, we measure and record the original length of the spring without any load. So measure this length, and then hang a mass, a non-mass. Measure a non-mass on the spring. Sorry, hang a non-mass on the spring and allow it to come to rest. So when a mass is added to the spring, it's going to stretch. So let it come to rest and then measure the new length and calculate extension. Remember that extension is the new length minus the original length. That will give you the increase in length, which is this bit here. So repeat the procedure using several different non-masses, recording the corresponding extensions each time. You cannot base on just a single measurement. That's why you need to repeat the process, the procedure, using different non-masses. You can start with 10 grams, 20 grams, 30 grams, and so on. For each, you find the extension. Remember, extension is the length, new length, due to the mass hung on it, subtract the original length. So then you calculate the force, which is the weight, for each mass using F is equal to mg. This is like weight. Weight is equal to mass times acceleration due to gravity. And then tabulate the values of force and extension. You write the values in a table. Having done that, you plot a graph of force in newtons on the y-axis against the extension on the x-axis. So you are going to have a graph plotted. Then draw the best fit straight line through the plotted points and determine its gradient. So the gradient of the force extension graph gives us the spring constant. 3 marks from the diagrams. Then you have 7 points. I think there should be 7 points to give you a total mark of 10. But written presented in the way we have done here, it will be up to the discretion of the examiner whether to give 2 marks to the diagram and 1 mark for each of the points raised in the description. Welcome, learners. So write your steps logically, neatly, in order to get all the marks. And also remember to draw your diagram properly in the pencil and label the paths using ink. Avoid drawing diagrams that are awkward. Examiners don't wish to pay attention to an awkwardly drawn diagram. So draw your diagrams properly. Question number 2. With the aid of well-labeled diagram, describe an experiment that can be done to show that pressure of a fixed mass of gas is directly proportional to its absolute temperature when volume is constant. This is what is known as the pressure law, also known as Gay-Lucas law. Alright, so describe with the aid of well-labeled diagram. So we have a need for a diagram. We have need for a diagram. Remember, diagram attracts 1 mark. When properly done, before labeling it, it's 1 mark. After labeling it, at least 3 parts correctly labeled, that's 2 marks plus 1, it gives you 3. So the setup is like this. You have a water bath as a source of heat, and then you have a colored liquid in the test tube. This is a test tube. Inside it, there is a gas which is tightly sealed using a rubber band, and then this is connected to a U-shaped manometer with a scale on it. The manometer should be open at the one end so that it is subjected to atmospheric pressure. That's the setup. 3 marks. Correct diagram with before labeling. Before labeling is 1 mark. The diagram fully labeled is 2 marks. Altogether you have 3 marks. So you need 7 points in the description for you to scoop 10 marks. So set up a sealed test tube containing a fixed mass of gas. Set up a sealed test tube. So this is a sealed test tube containing a fixed mass of gas. Remember that the mass of the gas must not change. In other words, this must not be open to the outside because there will be transfer of particles either out or into the test tube. So that's why you have to seal this one here. This must be airtight. Alright, so set up a sealed test tube containing a fixed mass of gas connected to a U-tube manometer, and immerse the test tube in a water bath. The water bath is a source of heat in this case. And keep the volume of the gas constant. So keep this volume constant using a ridge test tube. sealed with a tight rubber band. So this volume must not change, must not vary. The variables that you are investigating here are pressure, which will be measured by the U-shaped manometer, and the temperature. So we must keep the mass of the gas constant. We should also keep the volume constant. So heat the water bath gradually, slowly, to different temperatures and allow the gas to reach thermal equilibrium at each temperature. Measure and record the temperature of the water bath and the corresponding gas pressure from the difference in manometer liquid levels. Measure and record the temperature of the water bath. So it is this water, a medium whose temperature you need to measure, and then you measure the corresponding column difference. Repeat the measurements for several temperatures while ensuring the volume of the gas remains changed. Remember, the volume of the gas must remain constant throughout the experiment. Convert all temperature readings from degrees Celsius to Kelvin. You do that by adding the measured temperatures by adding 273.15. That will give you the Kelvins, but you can just add 273 without the decimal part. So convert the temperatures. So the temperatures that you get, add 273. So you will have a table, and then you also find the corresponding pressures. The pressures will be simply the difference in the column levels of both sides. The pressures will be the column levels, both sides. And it will be in the millimeters of mercury. Then plot a graph of pressure against absolute temperature, meaning that the pressure values in the atmospheres, rather in the millimeters of mercury, will be on the y-axis, and temperature will be plotted on the x-axis. So a straight line through the origin shows the pressure is directly proportional to absolute temperature when the volume is constant. This is called pressure law. It is also known as Gay-Lucas law. So correct diagramming and the correct points together will give us 8 marks, rather 10 marks. Thank you very much, learners. Welcome to Blantyre Secondary School mock. The paper contains 7 pages. It also has 4 questions, as a money paper ought to be. Number 1, describe an experiment that will be carried out to verify Archimedes' principle. Remember, Archimedes' principle has to do with bodies immersed, partially or fully immersed in fluids. It states that a body fully or partially immersed in a fluid experiences an upthrust, which is equal to the weight of the displaced fluid. So how do you verify that statement? So you are going to use a Eureka can, which is also called an overflow can. Remember, there's no need for us to draw a diagram, so we are going to rely totally on description. So fill a Eureka can with water until it just begins to overflow at a point called spout. So fill a Eureka can with water until it just begins to overflow. Allow the excess water to drain away and place an empty measuring cylinder beneath the spout. Make sure you refer to the diagram in your notes of the Eureka can. You can get it from textbooks as well, such as Excel, Succeed, Achievers, and any other good physics book. So allow the excess water to drain away and place an empty measuring cylinder beneath the spout. Then suspend a solid metal block from a spring balance using a thread. You are doing this in order to measure the weight of the metal block in air. So record the weight of the block in air, call it W1. Then carefully, while the weight is still hung or suspended to the spring balance, lower the block gently until it is completely immersed in the water without touching the sides or bottom of the can. So lower it carefully. Then collect the overflow water in the measuring cylinder. Remember that upon lowering a block into the water, some water is going to be displaced. So you collect that water which has been displaced in a measuring cylinder. Then record the apparent weight of the block in water. So when you immerse or lower the block into the water, you take a reading again, which is the weight of the block in the water. So you have two weights here. You have its weight in air and its weight in the water. Right, so measure the volume of the displaced water and calculate its weight. All right, how do you calculate weight? Weight is simply mg. So you take the mg, remember, m is mass and g is the acceleration due to gravity, or what is called the gravitational constant. So we shall rely on the volume measured and density of water. Remember, mass of water is its density multiplied by its volume. So the volume is measured by the cylinder, measuring cylinder, and the density is already known. The density of water is 1,000 kilograms per cubic meter. Or if your volume is in grams per, if your volume is in cubic centimeters, then you shall use a density of 1 gram per cubic centimeter to find mass. So once you find the mass, multiplied by 10, it will give you the weight of the displaced water. Then calculate the loss in weight of the block. There appears to be some loss of weight, which is called apparent loss in weight. You find that by taking the weight in air minus the weight in the water. And then you compare that weight with the weight of the displaced water. Right? So if the loss in weight, which is called the upthrust of the immersed object, is equal to the weight of the displaced water, then Archimedes' principle is verified. What does Archimedes' principle state? It states that an object partially or fully immersed in a fluid experiences an upthrust which is equal to the weight of the displaced fluid. Welcome, learners. Question number 2. With the aid of a well-labeled diagram, describe an experiment that could be carried out to determine the center of mass of an irregular object. Remember, center of mass is a point on an object where the mass of the object seems to be concentrated. So in that case, we shall use what is known as the lamina. This is an irregular object whose center of mass is to be determined. This is just a pin which is held in place by a clamp, and then we have a string at the end of which is a mass. It forms what is called a plumb line. So this string is getting all the way from point A down vertically. So this is the diagram you shall need to draw. So suspend the irregular lamina from point A using a pin held by a clamp and allow it to hang freely. So suspend the lamina, this thing, this you can get from a carton, just cut out nicely from a carton, cardboard, and then you suspend it here using a needle or a pin which is held in place by a clamp and allow it to hang freely. Welcome, learners. Then hang a plumb line. A plumb line is a string at the end of which there's a mass. So hang a plumb line from the same pin so that it hangs freely. So this is a string to which a mass is attached. That's called a plumb line. So a string will go all the way due to the weight of the mass. The string is going to be vertically straight. Then when the lamina comes to rest, draw a line along the plumb line on the lamina. So draw a line along this string. This line is called a locating line. We're trying to locate a point on the lamina where the center of the mass lies on this object. So remember the pin, remove the pin and suspend the lamina from a different point. So you rotate this, bring point B there, do the same, repeat the procedure to draw a second rotating line. You also do the same with point C. So bring point C there. So you're going to have 3 lines altogether. All right. So the 2 locating lines are going to intersect at point G. This is the center of mass or center of gravity of an irregular lamina, so this point here, such that if you support this point on a finger, the object is going to balance at that point, as if all its mass lie on that particular point. So suspend the lamina from a third point, like C, and draw another vertical line, checking line using the plumb line again. So where all these points meet, if the checking line also passes through G, this confirms that G is the center of mass of the irregular object. Welcome, learners. So three marks will go to the diagram. Correct diagram before labeling. It's 1 mark, and 3 labels will give you 2 marks, like altogether 3 marks. So each of the points is 1 mark, giving you a total of 10. Welcome, learners, once again. All right, I also brought this paper to you from a school called Tandeka Private Secondary School. This was their paper there. It's a beautiful paper. That's why I brought it here for us to look at it together. It also takes the form of a money paper. having two sections, A and B, and also requiring you to answer all the questions, the 4 questions. Beautiful paper there from Tandeka Private Secondary School. Give respect to the teachers who formulated this paper because it has very good questions, which I thought could be important and of benefit to us as we prepare for our practical papers next week. So question number 1, with the aid of well-labeled diagram, with a well-labeled diagram, describe an experiment that can be used to verify Ohm's law. Beautiful question here. So Ohm's law states that current through a conductor, metallic conductor, is directly proportional to the potential difference across the conductor as long as temperature and the other physical factors are kept constant. That's Ohm's law. So how can we verify that? With the aid of a labeled diagram. So the diagram that is going to help you describe this process, the experiment is this one here, making sure you have a battery to act as power supply source. It's direct current. It can be a cell, good one, or battery, several cells connected together. And then you have an ammeter correctly connected in series with the rest of the components. And then you have a test resistor there, across which you have a voltmeter and a switch. So by drawing a diagram, correct circuit, 1 mark, and then the 3 labels, 2 marks together, it will give you 3 marks. So connect the circuit as shown with the ammeter in series and voltmeter across the resistor here. Close the switch to allow current to flow through the circuit. Close the switch to allow the current to flow through the circuit. Adjust the power supply. You can use so this can be some kind of variable resistor like a rheostat to obtain a small current. So adjust the power supply. Remember that a rheostat can enable you to adjust the resistance, the length of the wire, and in the process also adjust the current flowing through. So adjust the power supply. Measure and record current from the ammeter and the voltmeter from the voltmeter. Sorry, measure and record the current from the ammeter and the voltage from the voltmeter. Increase the voltage gradually and record several pairs of voltage and current readings. So you shall have a table containing voltage and the current. And in each case, you plot a graph of voltage against current using recorded values. So you have several values. You can have up to 5 values of voltage and the corresponding values of current. So if the graph is a straight line passing through the origin, then Ohm's law is verified. Ohm's law states that current is directly proportional to voltage as long as temperature and other physical conditions are kept the same or constant. Number 2, describe an experiment to show that sound cannot travel in a vacuum. Remember that a vacuum is a space that is void of matter. It doesn't contain matter in it. So such a space cannot allow sound to travel through. Alright, so set up an electric bell inside. Here again, you don't need a diagram because the question has not specified that we should draw a diagram. So set up the electric bell inside a bell jar. Right, connect the bell to a battery using connecting wires. You can also use a cell depending on the power rating of the bell. But for you to have reliable results, it's important to use battery. Close the bell jar tightly to make it airtight. Then switch on the battery so that the bell starts ringing. Switch on the circuit. Okay, or close the switch if you want, so that the bell starts ringing. Listen to the sound of the bell before removing the air. So there's air in the bell jar, right? There are particles there. So you listen to the sound. As the bell is ringing, use a vacuum pump to remove air from the bell jar. Then listen to the sound as more air is being pumped out, it's being removed. Alright, listen to the sound, whether the sound is increasing or decreasing. Continue pumping out until almost all the air is removed from the jar. Alright, listen to the sound again. As more and more air is being removed, listen to the sound of the bell. So if sound is not heard when the air is removed from the bell jar, then sound cannot travel in a vacuum, because sound requires a material medium such as air to travel through. Let me call upon you to also look at the diagram, because the question can say with the aid of well-labeled diagram. So you shall need to draw a proper diagram and then you give this description. Welcome, learners. Before I go, I want to leave you with this question. Questions from St. Patrick's Secondary School, one of the best schools in the country. Have not provided solutions to this paper. I want you to do it in your own time. You can share with me the answers. Alright, so this is a paper from St. Patrick's. Question number 1 is saying, with the aid of well-labeled diagram, describe an experiment that can be done to show that volume of a fixed mass of gas is directly proportional to its absolute temperature. This is another gas law, very important. So can you answer this question and share with me the answers to it? Number 2, describe an experiment that can be done to show that the sum of clockwise moments about a point is equal to the sum of anti-clockwise moments about the same point. This is what is called